Hey guys, this is a P3 replay for the other pericyclic reactions lesson. Um, this problem in particular was asking for some curved arrows and an intermediate associated with a 1,5 and ERC sequence. If you ever get to a situation where you need to draw a mechanism and don't have enough room to do it, using the View Sketcher Window option, or the BA Sketcher Window as we affectionately refer to it, is a great way to give yourself some more space to work on these problems. And in conjunction with that, using the Zoom All button, which is up here in the upper left between the plus and minus buttons on the toolbar, will really bring the mechanism to the forefront. So what we see here is a 1,5 rearrangement as the initial step taking place. You should keep in mind that the 1,5 rearrangement has a structural motif associated with it of two double bonds with a bond to usually a hydrogen or a methyl group on the carbon adjacent to the two double bonds. So two double bonds, an sp3 hybridized carbon, and a hydrogen or methyl group, and the hydrogen migrates across the pi system like so. So the electron flow is cyclic, but we end up breaking a sigma bond and moving it across 5 atoms. So it sticks to the hydrogen, but moves 5 atoms across the pi system. So what we need to do is look for this structural motif in the starting material, and you can actually see it. This hydrogen that is drawn in is really jumping off of the page as an important sigma bond, and indeed it's on an sp3 center next to two double bonds. This is the only motif in the starting material that is able to do a 1,5. So with that in mind, we can draw the product by first copying this, shifting the hydrogen over to the 5 position, and then moving the double bonds around to reflect the electron flow. Of course, it's more than possible and also correct to draw the electron flow the opposite direction. That's just fine. With this intermediate in hand, we now see that the next step is an electrocyclic ring closing, and you should keep in mind that the sort of structural motif for this idea is just a linear pi system, right? A linear pi system where one of the double bonds is used to close the ring and the other double bonds just cycle around, and what we end up with is a new ring of some size. In this case, I've elected to draw the 6 pi electrocyclic ring closing because that's what's involved here, but you can imagine it for longer pi systems just by adding double bonds to this general structure, right? And what we see if we look in box 2 is that there's really only one portion of the structure that can undergo an ERC, and it's this 6 electron pi system, 6 atom pi system here, where we're going to use one of the double bonds to form the new sigma bond and then flow the other two double bonds around to get to the product. In the product, the double bonds have shifted and we formed a new sigma bond derived from one of the double bonds of the intermediate. It's very important in this problem not to get thrown off by aspects of the starting materials that are really just meant to throw you off. In this case, there was an extra double bond attached to one of the double bonds involved in the 1,5 that was very easy to think that this must somehow get involved in the reactions. But in fact, if you know the structural motifs inside and out, then you can recognize that really that double bond has nothing to do with the 1,5 rearrangement. And likewise with the ERC, the carbonyl carbon has nothing to do with the ERC, and it just sits there throughout both processes.